Broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everybody. Welcome to our webinar this afternoon, Replacing Design Assumptions with Facts. My name is Rob Romanowski. I am the Director of Sales Operations for 3HTI. And today I'm joined with Cody Wiltrout, Application Engineer for PTC. And what we're going to do is we're going to give you an overview of Creo's Product Insight Extension and a little more detail concerning how that extension can fit into your digital transformation or Industry 4.0 strategy. So one of the reasons why I chose this graphic is this relates to a smart connected city, which can also relate to smart connected manufacturing, which relates to what a digital transformation strategy is. So digital transformation can mean many things to many people. So and different companies have different strategies, or maybe you don't have a strategy at all yet. And if you don't have a strategy, or if you do have a strategy, we're more than happy to help you implement this strategy quicker, especially with PTC solutions. And what we're going to look at today with the Product Insight Extension, this helps to give you the ability to collect real-world data from the test bed or from a product being in the field and bringing that information back into your CAD model. So this will support a digital thread, and it gives you real-world facts, not just assumptions. So in relation to digital transformation, this allows you to collect this information and share it digitally with people inside and outside of your enterprise. And this information can also be used if you're creating or using a digital twin for that product. And what we want to do is we want to help make your life easier. As you can see in the first paragraph of our mission, we really want to help improve your business and your profitability, but at the same time, help solve whatever problems you may have in your current product development process, help you collect information faster, and help you implement a strategy that's going to help you make your products more reliable, get them to market faster, as well as stay a step or two ahead of your competition. So at this time, what I'm going to do is I'm going to pass everything over to Cody, and he is going to take you through the PTC Product Insight Extension. So Cody, you now have the con.
All right, let me find the screen here. All right, can you see my screen now with the PowerPoint?
I most certainly do.
All right, I'm getting better at using GoToMeeting here slowly.
You're a rock star.
Thanks. All right, well, to introduce myself, my name is Cody Wiltrout. I'm with PTC's Virtual Center of Excellence, about 45 minutes outside of Pittsburgh, Pennsylvania, and I'll be going through Creo Product Insight today. So to get started here, a little bit of background into why the extension was created. So first off, whenever people design products, it's a lot of times based on assumptions. And I mean, they're not necessarily bad assumptions, but if you don't have real world data, you're using something that's an assumption, which might not always be accurate. So you don't know, all the time, are they good assumptions, especially if you do make changes from maybe one version of something to another. The assumptions you used in the past might not be valid for the new part. So going along with that, what do? Well, we test. We add sensors to either prototypes or to things that are out in the field, and we measure and record that information. But once you get all that information, how do you deal with it? You can end up with a data lake of information, and that is from the real world, but how do you actually utilize that in your designs and improve your designs going forward? Well, the solution to that can be found with Creo's Product Insight, which allows you to connect that real-world information and easily utilize it inside of Creo to make improvements. So some capabilities of this extension, it's an add-on extension to Creo, and it provides you specialized tools that allow you to design for connectivity. And you have sensors that can capture relevant data streams and return real-world data from your physical products and display that inside of your assemblies. To go along with that, you can replace your assumptions with facts from your actual data. And you can use Creo to optimize, improve, and respond to that data that you're getting back. So rather than just having the data and saying, well, this is nice numbers, actually utilize those to do something and make changes with your process or with whatever it is you're designing. You can easily define and place physical measures or sensors into your Creo assembly. So you can attach sensors into the assembly and then have the data feeds go to those. And you have a new instrumented assembly. So if you're not really planning on putting sensors on your final design that is going to go to market, that's fine. We have one-way associativity with instrumented assembly so that you can use your latest working design, put those measurements or those sensors into your assembly, but not worry about that affecting your existing design. To go along with that, you can have seamless connection to your sensors or data from those sensors, from data files. And if you're interested, you can also connect to sensors from ThingWorx. So for those of you who are not aware, ThingWorx is PTC's IoT platform. So it's a rapid application development platform, and it allows you to connect into either multiple systems or edge devices, whatever your sensors are on, and aggregate all of that data into a mashup for you. So I'll go ahead and jump into the demonstration. So for today's demonstration, my task is to be working with this throttle body that we can see here. And inside of this throttle body, I have the cylindrical opening with the butterfly disc here. And that opens and closes, and I've designed the disc to be exactly the size that I need it to be. But is it really going to work like that in the real world? Is it going to flawlessly open up, or am I going to have some issues with clearance or any problems like that? I could say maybe come in to simulate inside of Creo and say, oh, let's put a thermal load or let's put a structural load on this back here and let's see how that affects it. And that would be one way to go about testing this, but we can even take that a step further and say, well, let's take some sensors, put some sensors onto this, and let's get some sensors onto our real world prototype or onto the one that we're using in real life, and get some real information that we can feed into here and see how it's working and see if there are going to be any issues. So to do that, the first thing that we're going to have to do is bring a sensor into this model that can have that data coming into it. So we'll go ahead and start working with our first sensor. And with the sensors, they don't need to be complicated. So in our case, this is just basically an end cap. It can be as simple or as complex as you want. It doesn't have to have a really complex geometry, because what matters are the attributes that you're going to assign to those. So in our case here, we're adding an attribute around the angle that the disc is going to be at. And so it can then get information associated to that angle and put that into the model. Again, if you wanted to instead, if you intend on putting these sensors out into the field with your finished devices, you could fully model out the sensor as you wanted to. It would still work the same way. It's just up to you in how much you want to do with the sensors. If you're not really planning on using them, you can keep them simple. Then once you have the sensor in, you can simply constrain it to your model, and now we can choose which parameter in the model we want this to be associated to. So since this is for an angle, we're going to pick the angle on our disk here, and it'll be associated to that dimension now. So we can see it's brought up the sensor angle there for us with 50 degrees right now. And if we change the angle in our sensor, it's actually going to rotate our butterfly disc there for us. So if we change this from 50, say to 45, and we regenerate our model, we can see that the model is going to actively follow along with that and knows to rotate the disc. Now that we've got this sensor in here, we also want to put some measurements in here, because what we're really interested in whether or not we're going to have issues with this opening and closing. So we're going to put a measurement from the wall to the edge of the disc so that we can see if we're going to have any interference or any problems. So we'll go ahead and name this measurement off here, and now we can utilize that along with our sensor to get some information back. So far, we've started off just looking at our model. We've brought in a simple sensor. We've put in the angle and associated that angle to the specific dimension for the disc, and we've added a measurement that we're gonna be using down the road here in a little bit. To continue forward, the next thing we're gonna do is go ahead and add another sensor in here, and this is gonna be for that load that we talked about on the back wall. In our case, we're gonna be putting in a thermal load against it, so we'll put a temperature sensor here onto the body. And again, we can see that it's a pretty simple geometry in this case. It's just a rectangular cube here, and it's all it needs to be. We have the attribute that we want, the temperature, and that's all that really matters. So we associate that to the temp load, and now we have both of our sensors defined. You can also move where the display is at so that it looks a little bit cleaner, wherever you want it, so that it's easy for you to see. Now that we've brought in both of our sensors here, we have a measurement set up, the next thing that we're gonna wanna do is start bringing in data. So there's two different ways to do this. We could load data here, so you don't need to have ThingWorx, you don't need to have an IoT platform necessarily. You can bring in a CSV file with that data. So if you have data that you want to use, you can put it into a CSV file and then load that CSV file into here and be able to run that information. You can choose to run all of these, so you can choose to run all of them or individually points. Alternatively, we can switch over to ThingWorx. Again, that is our IoT platform, and we could choose to be bringing data in from our IoT platform instead of directly by publishing out CSV files and using those. Right now, we don't have anything here inside of our analytics manager. So what we're gonna do is we're going to go into our sensors and publish those sensors off to our profile. Whenever we publish these off, then they're gonna show back up in our ThingWorx server, and then we can start sending data down to them. So when we load here, we can come back to our models and see now we have that instrumented throttle that we're working with. And what we need to do is map that data. So we'll start by saying we're gonna create an event. So the event is gonna determine when that information is going to be sent in. And in our case, we're gonna choose that for any time there's a change in the data because we want all of that new data. Once we have the event made, we're gonna map the data. So we just choose map data, and it's pretty simple. We have our inputs and our outputs. So we're just gonna match the things here. So we have an angle and a temperature. Well, we want the temperature to go to our temperature sensor, and we want the angle data being brought in to go to our angle sensor. Once we have that all mapped out inside of ThingWorx, we can come back in, connect to our server, and start bringing that data down into Creo so that we can utilize that however we see fit. So we see that once we're signed in here, we have the data source, the event, and the information here, and we're just gonna send that to Creo. And we'll get a notification that our sensor data is now ready to be used. So once we have been sending that in here, we can load in our server data, and it's gonna look similar to the CSV file data here. And again, we have that option to choose to run a few points, or we can run all of it, whatever would work best. In our case, we'll run all of this. And you can see as we did that, that the disk rotated around as it went through those different angles. So it is actively, changing the model for us as we run through those parameters that change. Now that we've done this and run this data in, we want to go a step further. So we're actually going to also utilize another extension inside of Creo, Creo Simulate. With Simulate, we can take this real world data that we have, and now we can run through all of it fast and easy to see how it's going to affect our model. So to start, we're going to be working with that load on the back, the temperature there. And so the value we want is our temp load, which has all of that temperature information that we brought down from ThingWorx. That load's going to be on the back wall there, and it's associated to our our temperature sensor. Once we have that loaded, we can simply run our diagnostic simulation here, and it'll go through the information for us. It should be pretty quickly here, only take a few seconds, and we've got our results. For those of you who haven't seen Simulate before, it's pretty nice to be able to view results. You can set up different views on how you want to see that. Right now, we're looking at the temperature range here, but you can also change that. So rather than seeing a thermal spectrum, we could see a structural spectrum depending on what you're doing, however you want to view that information.
The other thing, if I can interject about Creo Simulate, is that this is a tool that is made for designers using Creo or engineers to be able to run a simulation analysis early in the design stage. So you don't need to be you don't need to use a FEA expert with a complex tool. This tool is it's complex in what it does, but it's very simple to use. And the whole idea behind it is that if your product downstream needs to go to an FEA specialist or an analyst, then the designer and the engineer have designed for function, not just form and fit. So if there's any changes that need to be made, they're minor, instead of having to go back to the drawing board and then have the analysis be done again downstream. So once again, this is a tool that's pretty easy to use, and it's basically to help designers design not just for form and fit, but also for function.
Yeah,
that's my commercial.
Absolutely. That's a great point. You know, and you never even have to leave Creo, which is nice as well. So you don't have to worry about exporting your models and having any failures or problems. It's all right inside of Creo. And as you said, you know, it's simple, easy to use, meant for engineers who are used to working inside of, you know, your CAD software. Now that we've gone through our simulation on our thermal analysis, we can also do a structural analysis here. And what we're going to be looking at now is that interference that we were talking about earlier. So we've already set up a few measurements here, such as the vertical displacement at the top and the vertical displacement at the bottom of the disk here. So we're going to utilize those in checking whether or not there's an interference problem or if that's going to be able to open and close. So now that we have those measurements that we want to use, we're going to go ahead and set up one more analysis measurement here. And what we're going to be doing with this analysis measurement is we're again checking to see if there's any interference here. So we can come in and we can compute for all of these that we've set up around those displacements. So we have it running through our analysis. Again, it's pretty quick, and we'll get back those results, and we can see those displacements at the top and bottom. But this isn't really the ideal way to see that, you know, seeing those numbers with the displacements. It'd be much easier if we could say yes or no. You know, that's really the answer that we're looking for. Is there an issue? Is there not an issue? So what we're next going to do is set that up. We'll say, hey, well, let's set up an analysis that says, take this information, create a relation, and say, yes, there is an interference issue, or no, it's fine. It can run, you know, it'll open up fine. Once we have this set up, we could just run it and check, but, you know, we don't really want to be running this for one point at a time since we have all of this sensor data. So let's go ahead and actually put in another sensor and use that to display our results in an easy to read manner. So we're going to add in our last sensor here that we're going to be using today. And this one doesn't even really have geometry to it, but that's fine. We can just place it inside of our model here and start defining those parameters that we're using. So the next thing that we have to do is come in and select the features that we're going to be using. In our case, the clearances, the displacements, and that final yes/no result for whether or not it's going to have interference. So we can select each of these individually. Again, just choose parameter, select what feature we want. We can come down, see that we have all of our different features here, and we're going to be choosing our vertical displacement at both the top and the bottom for the next two parts for the sensor here. And you can see that as we choose each of those, they go from being undefined to defined. And again, you know, some of the utility here just being very easy ways not only to bring in this information, to be able to run this information, but then to be able to display this information back so that you can actually work off of the results that you're getting and really make changes that you need. So we're going to select the last point here, which is the last feature that we have, which is the analysis that we just set up for the yes/no statement. And once we set that in there, we can now go ahead and say, hey, we've got all of these defined. Let's go ahead and run through that data that we loaded in and see what results we get back, see if we have any issues or not. So we'll go ahead and do that now. So we have our data, again, that we brought in from ThingWorx, but again, you don't have to use an IoT platform. You could just choose instead to bring in a CSV file with your data. And then we can choose, in this case, rather than running all of it, we'll just run a few points here and get that information back on those. So you can see it filling in the columns with the data. And once it's done running through there, we can see the check mark to show that it's run for those two. And we can see that actually we do have a problem. There is a sensor issue for one of these points here. So we aren't going to be able to have that disk opening and closing as it's designed right now. Maybe I need to go back and make some changes either to it or to the body, whatever it is, that I want to go forward with to finish this off and improve it. But, just a fast, easy way to get all that information in, be able to run all of that information and be able to get those results back in a manageable way so that you can act on them. So to close off here, I'll go with just a few more PowerPoint slides. Some value that this tool can really bring is that you can validate your design requirements by replacing those assumptions with real-world data. And that ensures that your new product designs provide the necessary data streams. So, as the world moves forward, more and more data is becoming important, but just having that data isn't enough. You really need to be able to use that data, and this really streamlines that process so that you can go from collecting the data to actually utilizing it in your design process. This also means that you can improve the quality of current and next generation products by identifying and correcting any design flaws. Just like as we saw with the disk there, depending on what information or assumptions I might have been running on, I might not have realized that there had been an issue beforehand and then could have problems down the line. I can also identify business opportunities for new products, features, or product extensions based on this by being able to have more insight into what's actually happening with our products. That covers the high-level overview for today for Creo Product Insight. I hope it was a good demonstration for all of you.
Cody, I think you did a fantastic job. Thank you very much.
Yeah, absolutely.
So if you have any questions, feel free to type those into the dashboard, into the question box. And what I want to do is just, I guess, close off the webinar at this point. If you have any questions or would like us to, if you'd like to have a discussion more about your digital transformation strategy, anything about the Product Insight Extension, or just anything about Creo in general or your manufacturing process, feel free to contact us. We're looking to be a trusted partner for you as we are with our current customers. They rely on us when they have new initiatives that they're implementing into their design process or development process. How we can help them. We are a full service organization. We have experts in every area of manufacturing, starting with design to analysis through manufacturing. We could give you more information on Internet of Things, how that can be implemented for your business. And you don't need to be a large entity to be able to, use the Internet of Things. There's a lot of small and medium-sized companies that are utilizing this technology, and we're more than happy to share that knowledge with you. So if you'd like to reach out to us, our email address is info@3hti.com, or you can call us toll free at 866-624-3HTI, or you can contact me personally and be more than happy to help you guys out. So Cody, once again, thank you for your help. Thank you for a great presentation, and most importantly, thank you to our audience. Have a great afternoon, everybody.
Absolutely. Thanks for your time, everyone.